Hi, my name is Faraz Khan, and today in this video I will be teaching you how to decompose a relation into 3NF form. So let's get started. So we have been given this relation R, which will have to decompose into 3NF form. So the given relation has some functional dependencies as follows, and our goal is to determine which which normal form is the relation present in, and how can we convert this relation into 3NF. So the process of converting a relation into 3NF involves decomposition. That is, we will have to decompose the given relation into smaller relations so that the conditions involving these normal forms are satisfied. So step one of our solution is converting or finding out the candidate keys of this relation. So we have found out the candidate key of this relation. It is AB. That is, using the combined value of AB, we can find all the other attributes of this relation. So this is the definition of candidate key, and the attributes which are present in candidate key are known as prime attributes. Therefore, A and B are prime attributes. So for first normal form, all the attributes of the relation must be atomic. So in the given relation, we do not have any multi-valued attributes. Therefore, the given relation is in first normal form. Secondly, in order for a relation to be 2NF, there should not be any partial dependency. That is, the attributes must not be determined by any prime attributes. They can only be determined by the candidate key. So in our relation, we have two functional dependencies, A determining D and B determining F, which violates this condition. So in order to fix it, we will create a relation corresponding to each of the functional dependency. So for A corresponding to DE, we have this relation, and for the second B determining F, we have this relation. So using A, we can determine DE. So A, D, E are present, and using D, we can determine IJ. Therefore, A, D, E, IJ belongs to one relation. Similarly, using B, we can determine F, and using F, we can determine GH. Therefore, B, F, GH are in one relation, and remaining attributes A, B, C, that is A, B determining C, is in one relation. So we have successfully converted the given relation into 2NF form by breaking up the table, that is decomposing the given table into smaller ones. So the condition that no partial dependency exists is now satisfied. Now, in order for a relation to be 3NF, there should not be any transitive dependency. And what I mean by that is A is determining DE and IJ is being determined by D. So this D is the middle point, which is transitive in nature. So for AD, we have DIJ. This must not be true. Similarly, for R3, we have F determined by B and G is determined by F. So there is transitivity involved, which we do not want. So if there is any sort of transitivity, then the given relation is not in 3NF. Therefore, in order to convert this relation into 3NF, we again have to decompose R2 and R3 into these functional dependency. So we create one relation for one functional dependency. So for ADE, we create a relation R2, and for DIJ, we create a relation R3. Similarly, for BF, we create the relation R4, and for F corresponding to GH, we create a relation R5. So finally, we are ended with five relations which we have decomposed our original relation into. Therefore, the final these R1 to R5 relations are now in 3NF form. So we have successfully converted our given relation R into 3NF form by decomposing the relation into five independent relations. Also, it is important to note that we have to do it step by step. We cannot dump directly from converting 1NF to 3NF. The transition should occur one at a time. Otherwise, there is a chance of the making mistakes. And also, in each step, you have to make sure that the condition for all of the normal form are satisfied before moving on to the next one. Thank you.